Hi, everybody. Welcome to our afternoon webinar where we're going to discuss today the US EPA's updates to the AERMOD modeling system. My name is Michael Hammer. I am a certified consulting meteorologist and senior meteorologist with Lakes Environmental Software. I have been with the company since 2011, and I've been working in the air quality modeling field for almost 20 years now. I also am going to be the incoming chair for the American Meteorological Society's Board of Certified Consulting Meteorologists for the 2025 year. Excited to be in that position. My role here at Lakes encompasses a number of different things. I help manage our technical support team, and I also help oversee our meteorological data processing operations here at Lakes Software. And I help with our product development, overseeing development on our commercial product line so that we can get timely updates to our products like AERMOD View and CalPuff View out the door. For those of you who aren't familiar with Lakes Software's offerings, we are mostly known for our commercial software products, including AirMod View, CalPuff View, IRAP HView, and other air dispersion modeling applications. We also supply IT solutions like the cloud-based Ambient Quality Management Information System, or AQMIS, which provides complete air quality management for all aspects of environmental management for people who need those products. It's also fully customized and modularized for whatever your environmental needs happen to be. And here at Lakes, we also provide extensive training opportunities within the air and environmental fields, including monthly online courses where we teach an introduction to the AERMOD modeling system, quarterly classes where we address CalPuff, and other training opportunities based on custom needs of our customers. So, we're going to spend about 30 minutes today going over the latest updates to the AERMOD modeling system. I'm going to start with a quick overview of what the AERMOD modeling system is and what has happened in the regulatory environment recently that has necessitated these updates. That's going to include an overview on the Guideline on Air Quality Models, which helps dictate modeling recommendations for air permitting activities in the United States and also has broader reach in how other jurisdictions interpret the use of air quality models. I'm also going to then cover the modeling system updates and look at how each of these updates to each component affects how the AERMOD modeling system is used. That's going to include an overview of AERMAP for terrain pre-processing, AERMET for meteorological data pre-processing, and its associated program AERSURFACE. I'm also going to touch on the AERMOD air dispersion model itself, and then we'll close out with a few additional remarks. So most of you are probably familiar with how the AERMOD modeling system is set up, but just as a quick overview, the AERMOD modeling system is developed and published by the United States Environmental Protection Agency. The full modeling system encompasses a number of different programs, not just the AERMOD air dispersion model itself, which we see here at the center of this diagram, but also its pre and post processing programs, such as AERMET, which helps format meteorological data and calculate boundary layer parameterization. It also uses some additional preprocessors, AERSURFACE for reading land use data, and AERMINUTE for processing wind data. AERMAP is the terrain data preprocessor for importing elevations of model objects into the AERMOD executable. And BPIP Prime is used for assessing the potential for building downwash against stack sources. So all of these components combined make up the full AERMOD modeling system. Now, AERMOD as an air dispersion model is the preferred air quality model for near field impacts, that is, within 50 kilometers of source emission releases, per the Guideline on Air Quality Models, which is also referred to as Appendix W. That is Appendix W to Title 40 of the Code of Federal Regulations, Part 51. The Guideline on Air Quality Models is used nationally in the United States for determining and dictating how air models should be used in the preparation and review of permits for new sources of air pollution, as well as state and tribal implementation plans and other air quality assessments. This helps bring information to both those seeking air permits and those issuing air permits by setting the guidelines and recommendations for how air modeling should be conducted. By providing this information, it gives everyone a level playing field to better understand how to efficiently execute these models and what models to be using in the first place. Now, recently, back on November 20th of this year, a revision to the guideline on air quality models was signed by the US EPA administrator, and the final rule revision was put into effect. This change in the guideline is what necessitated the changes to the AERMOD modeling system that we're going to discuss in this webinar. Specifically, the guideline final rule revision approved 3 formulation enhancements for regulatory use. This includes the R-line mobile source type, the generic reaction set method for NO2 conversion, and the core algorithm for assessing overwater marine boundary layer parameterization. In addition to these changes to the AERMOD modeling system, the guideline revisions also incorporated new background concentration calculation recommendations. All of the details about the guideline revision can be found on the US EPA's website at the URL you see here. And this webinar is being recorded, and we will post this to our YouTube channel later after this webinar has concluded so that you can reference that URL. It's a great link to access all of the technical support documentation and information about the update to the guideline and understanding how this came about and what the potential impacts are. So, as I mentioned, on November 20th, that update to the guideline was signed by the administrator. Concurrently to that update, the US EPA published new executables and code for the following programs: AERMOD, the air dispersion model; AERMET, the meteorological preprocessor; AERMAP, the terrain preprocessor; AERSURFACE, the land use calculator; and MIF, which is used for formatting prognostic meteorological data from the WRF and MM5 meteorological models for use in other air quality applications. Each of these updates was affixed with a new version number dated 24142, although you can see here MIF has its own versioning system, so MIF was updated to version 4.1.1. These other applications, though, are now all listed as versions 24142, and if you're not familiar with that versioning system, it is a 5-digit number representing the 2-digit year and the 3-digit Julian day when the model code was locked into place. Now, if you do the math on that Julian day, you'll find that the 142nd day of the year is in mid-May. So there was a delay of a few months between when the code was locked into place and when the documentation was finalized and those updates published. A lot of that delay had to do with the pending guideline action and waiting on the signature from the administrator. Once that was finalized, then these versions could be posted to the US EPA's website, www.epa.gov/SCRAM, for the Support Center for Regulatory Atmospheric Modeling. That's a great website where you can find links to all of the documentation, all of the test cases, the code, the executables themselves, and additional information about air dispersion modeling. So, knowing that these new executables and code are published, let's take a closer look at what kind of changes were implemented. Now, when new versions of the AERMOD modeling system are enacted, there are 3 types of changes that we could potentially see here. These include bug fixes, corrections or fixes to previous known coding issues; formulation updates, when we have new model features, new components to existing model options, and updated algorithms. These are fundamental changes that modify some way that a calculation is performed by the model itself. We could also have enhancements, which are minor updates to existing options. These types of enhancements typically don't change the calculation necessarily. They make the model easier to use or provide some form of enhancements to how a model option is configured. So let's look at the changes that were implemented to the AERMOD modeling system with the 24.142 updates, starting with AERMAP. Now, the most significant thing about the AERMAP change is that this is the first update to this program in quite some time, nearly 7 years since the last update, and that 18.081 version of AERMAP was a fairly minor update that just did some internal formatting to the input file and output file. This change is a bit more substantial, starting with the fact that AERMAP now supports 3 additional source types in its interpolation scheme. That includes the line, buoyant line, and R-line source types. In prior versions of AERMAP, these source types were not explicitly interpolated or had elevations calculated for them, so those had to be done manually or through some modification process. In addition to support for additional source types, this update to AERMAP also makes the receptor pathway optional. All prior versions of AERMAP, those prior to the 24.142 release, required at least one receptor to be present. You always had to have some kind of receptor information in order to let AERMAP run. That requirement has now been lifted so that AERMAP could be run solely for your sources or solely for your receptors. This means if you've built out a facility and added all of your emission sources to a particular project, you could run AERMAP on just those sources and not also have to include some dummy receptor to get the model to run. Some additional bug fixes were also implemented because the EPA found some inconsistencies in the way that flagpole heights and the evaluation file discrete receptor type was also handled within the model, so those have been addressed. Next, we have AERMAP, and the most substantial changes to AERMET, are addressing upper air data. Now, AERMET, as configured, supports 3 different data file formats for reading upper air data observations, those recorded from weather balloons and radio sonde equipment. The primary form of upper air data that most modelers were using was called the Forecast Systems Laboratory, or FSL, data format. Unfortunately, earlier this year on September 30th, the National Oceanic and Atmospheric Administration permanently discontinued the FSL database. If you go to the website where the FSL database was hosted, you now receive an error message indicating that the database is no longer available and that the data is gone. Thankfully, back in 2022, with the 22.112 release of AERMET, the EPA implemented a new data file format for upper air called the IGRA format, as published by the National Centers for Environmental Information. So this format is available. It includes worldwide upper air measurements, and it's pretty simple to locate the data you need and insert that into AERMET. Unfortunately, one issue that was found within the 23.132 version of AERMET was that many sites in the IGRA format have a missing base elevation. There's no surface level elevation incorporated into many of the radio sonde readings. Since AERMET required that surface elevation to be present when assessing upper air data, this would result in a number of soundings being skipped by AERMET, and the end result was a large number of missing hours. If there was no surface elevation present, AERMET could not initialize the convective boundary layer calculations. It would simply skip the sounding, and without those convective boundary layer calculations, you lose about 8 to 14 hours per day of convective parameterization. AERMOD then recognizes those hours as missing and simply skips them. In order to address this, the EPA has recoded AERMET to now require a station elevation be present when identifying the upper air station of note. This is the location card taken from a sample AERMET input file. We have a station ID number. We have latitude and longitude. We have a time zone adjustment because the upper air data file formats being read by AERMET are all logged in GMT or UTC time. So we input the conversion to local time. This station is in the Eastern time zone, so we add 5 hours to local time to reach that GMT or UTC hour. And then here we have highlighted in red the new required station elevation being input to that location card. So this must be included starting with the 24142 version of AERMET. Other changes to AERMET include enhancements for the core algorithm for assessing overwater marine boundary layers, some changes to the way that those options were selected, additional informational and warning messages added, and some additional bug fixes related to the core algorithm. Additional bug fixes included a fatal error issued when your final SFC and PFL output files contain non-numeric characters. This will make it easier for modelers to identify potential issues in their meteorological dataset, as prior versions of AERMET didn't really present a warning when non-numeric characters were present in these files. You wouldn't learn that until you tried to run AERMOD, and AERMOD would issue a fatal error that some of the data in your MET files was not accurate or could not be processed. So now when characters like asterisks or NaN, not a number values, are included in the SFC and PFL file output, AERMET will issue a fatal error, and then you'll have an indicator to fix something about the way the data was processed. Additional information about AERMET changes can be found on the full AERMET webpage. In addition to the AERMET changes, there are changes to AERSURFACE as well. Now, AERSURFACE is a non-regulatory tool that assists modelers in calculating surface characteristics that must be included in the AERMET processing. These include surface roughness, Bowen ratio, and albedo. AERSURFACE works by reading digital land cover data files and calculating the appropriate surface characteristics for a particular location. The changes to AERSURFACE include separating out data type and year as input keywords. The prior version of AERSURFACE had fixed keywords for identifying the type of file you were using. This was done, this decoupling of data type and year, to better support the new land cover database products that I'll touch on momentarily. This makes the input file format more flexible for users. There was also a minor renaming convention applied. In prior versions of AERSURFACE, you could identify a particular surface roughness sector as existing in an airport or a non-airport location. Those names, those flags, have been renamed to low Z0 and high Z0 to better reflect how those flags were meant to be used. The purpose of the low Z0 and high Z0 flags is when you encounter developed land use, you can identify that developed land use as being low in height or high in height. The low Z0 corresponded to the airport flag because when you have an airport, you have developed land use. You have runways and tarmacs that are impervious in nature, but they don't have the height associated with like an urban developed boundary layer. They're very flat. And so by indicating low Z0, you can properly indicate that the land use is not as high in height, but still represents some sort of development. There's also run verification added to the AERSURFACE model using the run or not keyword that many of you may be familiar with. This allows you to verify the run in advance so that you can check for possible errors or warnings without actually performing calculations. and improved data file reading to make the process more efficient and to ensure that the data being read satisfies the calculation requirements. Now, along with this air surface update are changes to the National Land Cover Database as published by the Multi Resolution Land Cover Consortium Group. Previously, MRLC's NLCD data products were only issued about every 3 to 5 years. There were very specific data years 2001, 6, 11, 16, 19, where you would get updated versions of these products. But earlier this year, MRLC announced that they have now issued annual land cover products, which cover the period from 1985 to 2023. When you combine that with a relatively recent addition to AERMET, which allows you to differentiate surface characteristics by year, this means you could now potentially run AERSURFACE on an year by year basis using actual land cover data for the years being processed. If I were running 2019 through 2023 as a 5 year period of meteorological data, I could align air surface calculations with individual land cover products from each year to see how the change in land use could potentially affect the change in surface characteristics. Now, existing guidelines for the combining of data products still remains in place. By that, I mean that air surface can read digital land cover data as well as digital impervious surface percentage and tree canopy percentage data files. These tree canopy and impervious surface data files help enhance the calculations by clarifying what areas contain what exact types of land use. But existing guidance calls for those product years of impervious and tree canopy data to align with the land cover data itself. So if I'm using 2021 land cover data, I would want the 2021 tree canopy and the 2021 impervious surface data to combine with that. For users of our AERMOD View and AERMET View applications, WebGIS is going to be expanded in the near future to incorporate the new annual NLCD data. Now on to AERMOD itself, first addressing the minor bug fixes that have been found within the model. The first bug is not something I ever thought would have to be addressed any time around now, but yet there was a Y2K bug in AERMOD 23132. If you were processing data that spanned 1999 to 2000, AERMOD would interpret the 00 year as 1900 and issue a fatal error because 1900 was not a leap year and 2000 was. That has now been addressed. The buoyant line source also underwent some bug fixes, as that source type was ignoring modified emission units as found on the source pathway's emis unit keyword. So if you were modifying your units from the default grams per second input and micrograms per cubic meter output, your buoyant line sources were not reflecting that change in earlier versions of AERMOD, but that has been addressed. R-line underwent some minor adjustments as well for the resetting of the mixing height, and the generic reaction set method for NO2 conversion now has some additional checks for preventing not a number output. The more significant changes to AERMOD come from those model formulation changes that were brought into place with the new guideline. The first new regulatory default option is the R-line mobile source type. The R-line mobile source type is now implemented for regulatory modeling of mobile sources in addition to the existing area, line, and volume source types. So this is not meant to replace those existing source types. It's just providing another option to modelers out there so that modeling can be a bit more flexible. R-line was developed for near surface releases with an emphasis on the near road environment. Having been brought into regulatory default mode, R-line also works with the urban dispersion coefficient and elevated terrain, but the US EPA will point out that the existing PM hotspot guidance for mobile source modeling continues to recommend the flat option be used. So you may still need to switch into non-default mode to utilize flat terrain according to that PM hotspot guidance as necessary. The second option brought into regulatory default is the generic reaction set method for NO2 conversion. This method was developed by the Cambridge Environmental Research Consultants, or CERC, and it uses chemistry found in the United Kingdom's Air Dispersion Modeling System, or ADMS. GRSM has been present in AERMOD for a while as an alpha and then a beta option. The primary motivation for the incorporation of GRSM into AERMOD was to address photolytic conversion of NO2 to NO and also address the time of travel for NOx plumes when assessing NO to NO2 conversion via ozone titration. So, with this status elevation, GRSM is now considered a Tier 3 modeling option on par with the ozone limiting method, OLM, and the plume volume molar ratio method, PVMRM. The difference is that OLM and PVMRM have incorporated ozone titration as the primary means of assessing NO2 conversion, but they don't address photolytic conversion, nor did they take into account time of travel for that titration process. The third elevated model option is the CORE meteorological algorithm. CORE stands for the Coupled Ocean Atmosphere Response Experiment, and it is used in meteorological data pre-processing to assess overwater marine boundary layer environments. AERMET, when run in its default mode, assumes a land-based system and convective parameters are calculated over land. By bringing core algorithms into AERMET, this can enhance AERMET's ability to assess what the marine boundary layer is doing. The intention is for AERMET to then replace the standalone AERCore program and eliminate the need for alternative model demonstrations to use AERMOD in marine environments. This is part of a larger ongoing effort by the US EPA to sunset the Offshore and Coastal Dispersion Model, or OCD. If you read the guideline, OCD remains the preferred model for overwater dispersion assessments, but OCD is a pretty dated model, has very old code, and it's a difficult application to run on modern hardware and system architecture. So the EPA's intention is to eventually replace OCD with AERMOD in the guideline for offshore modeling demonstrations, and this is one step in that process. So as shown in the image here, which was provided by a previous EPA presentation, non-default options are typically affixed with the alpha or beta flags when utilized in the AERMOD model. And each one of these options has at some point been a part of that alpha-beta paradigm. But now with this update to the Guideline on Air Quality Models and the new version of AERMOD 24142, they have all been upgraded to regulatory default status. So those are the primary changes to the AERMOD modeling system, and our team here at Lake Software is hard at work on our new versions of AERMOD View and AERMET View. And we will be releasing a new AERMOD View version 13.0 later this month. Once we have everything tested and ready to go, an announcement will be made at the time of release. We'll make that on our social channels, as well as an email announcement to all of our customers. We will be incorporating these new 24142 versions of the models, both 64 and 32-bit, into the software applications, and we will have support for all the new features that I have discussed in this webinar. We'll also be including a new version of the AERMOD MPI executable, as well as an update to the AERMAP MPI executable. Those are both parallelized versions of the AERMOD and AERMAP models, respectively, and they can be used on up to 8 processors. Other additional GUI features and minor updates will also be documented at the time of release. So we look forward to getting that out to you as soon as possible. And that is what I have for you today. I hope you've enjoyed this presentation and that you have a better understanding of what these updates include for the AERMOD modeling system. Should you have any questions, you can send sales or maintenance inquiries to our sales team at sales@weblakes.com. Any technical questions you may have about these updates or anything about the AERMOD modeling system can be sent through to our technical support team using the email address support@weblakes.com, and we'll be happy to address those as soon as we can.